Okay, the question is, x is a random variable. And also we know the mean of x is 25 and the variance of x is also 25. And y is not a random variable, and we know the relationship between y and x. So in this case, you are required to find mu y and sigma x. So that's the mean of y and the standard deviation. So you got to be very careful. Sometimes I ask you for variance. Sometimes I ask you for standard deviation. So you have to get those things right. Okay, now because we know this is a linear function. I mean, there's a linear relationship between y and x. So we talk about the functions of random variable. So we basically just follow the rule to find out what is the mean of x and variance mean of y and variance of y. So we know expectation of x and variance of x. And we also know y is equal to x minus 25 divided by 5. So now we are required to find expectation of y. So in this case, we just plug in the formula there. So expectation of y is equal to expectation of x minus 25 over 5. So there are two parts, right? We say when w is equal to ax plus b, if you know this formula, then what is expectation of w? Expectation of w is equal to a times mu x plus b, okay? So there are two parts here, expectation of x over 5 minus 25 over 5. So if you want to go over the whole thing, you can do that. But since we already know the relationship here, so it will be equal to 1/5 times expectation x minus expectation phi, right? And expectation phi is simply equal to phi. So this is 1/5 times expectation of x is 25 here. 25 minus phi. So how much is that? It is equal to 0. Okay? Then about variance. Variance is a little bit more difficult. So variance of y, of course, is equal to variance of phi x minus 25 over 5. Okay? But you need to know if w is equal to ax plus b, expectation of w is equal to a times mu x plus b. But variance of w will be equal to a squared times vx. Okay? So this is the relationship. Remember, when it is variance, because variance of x is equal to expectation x minus mu x squared. So when there is a coefficient here, there's a constant here. When you move that out, you got square. Okay, you got square. So in this case, we have variance of x over 5 minus 5. And as you may know, this constant does not affect variance. Okay, this constant does not affect variance. So we move 1/5 out. 1/5 out, it becomes 1/25, right? And so Vx, and that will be 1 over 25 times 25 here. So that's equal to 1. As a matter of fact, if you get familiar with all these procedures, you know, we say to standardize, okay, to standardize a random variable. Originally, that is x, mu x, and sigma x squared. If we want to standardize it, then the formula is x minus mu x divided by sigma x. So in this case, what is sigma x? Sigma x is exactly equal to 5, right? And mu x is exactly 25. So what you get? What you get is the expectation will be equal to 0, right? And also the variance is equal to 1. And after this procedure, we get z. The mean is 0. The variance is equal to 1. So if you are familiar with all these things, then as a matter of fact, you should get to the answer right away. Okay? Any questions? Okay, let's try another one. Any questions? Okay. Okay, now we have three machines. We have A, B, and C. And these machines are used to produce products. And we know the probability that some of these products will be defective will be 0.05, 0.07, and 0.02 respectively. So what does that mean? For the products from A, from machine A, the chances that it will be defective will be 5%. And for B, the chance that it will be defective is 7%. And for C, the rate of defection is 2%. Of course, this is the rate of defection, defective products from these three machines. And we also know the chances that a supervisor, when he want to check the quality, what's the probability that he will choose A? So the probability that this person, when he want to check the product quality, the probability is 0.2, 20% that he will choose A, and 30% that you will choose machine B, and 50% that he will choose machine C. And so now a supervisor already select a product from all these three machines. And we know this product is already defective. We know that is defective. So then what is the probability that this machine going to come from A? So to get to the details of this, you can put down a table like this. We have machine A, machine B, and machine C, right? And so if it is a defective product, okay, but of course sometimes the product may be good, so it is good. So the probability that this one going to be good will be, for A, it will be 95%, okay? 95% it will be good, but 5% it will be defective. But we already know it is a defective product, right? We already know it is defective product. So now you have to know this column, right? How many defective products are there, okay? How many defective products are there? And so we want to know whether it is from A, right? So if you know the whole thing here, so you get this number, and then this number divided by this number, you get the probability. So this is a conditional probability, right? You already know it is defective, but now you want to know what's the probability that it will be from A. Okay, so now we have to know what's the probability here it will be defective, okay? If you choose machine A, okay, if you choose machine A, okay, what's the chance it will be defective? First, you have to know what's the probability you will choose machine A. The probability he will choose machine A is 20%, right? So this is the probability he will choose machine A. And what's the probability that when he chooses a product from machine A and it will be defective? 0.05, 5%, right? Okay, so this is the probability you choose A and also you get a defective product. And then what's the probability you choose machine B and also that it is a defective product? That's 0.3 times 0.07, right? And what's the probability he chooses C and also he get a defective product? That would be 0.5 times 0.02, okay? So this is the total probability that you will get a defective product, okay? But now you want to know whether that's from A or not, right? So basically when you look at a problem, you want to translate all the words into formula, okay? So when you look at this problem, you want to know, okay, given that this one is already defective, right? Okay, this one is already defective. And what's the chance you will get it from A, right? So then you need to know the probability that it is defective, and here it has to be A and it is defective, right? So it's very important that you can translate the words here and to get to the formula. So this is what you want to find out. And of course, if you know what you need to know, then you just start from all these things here, okay? And so basically, it will be very easy, right? You have to add these three things together, right? So the here, the denominator is 0.2 times 0.05 plus 0.3 times 0.07 and plus 0.5 times 0.02. And what's the numerator here? The numerator will be this one, right? So it's here. 0.2 times 0.05. Okay? Any questions? So what is this theorem? From here you know that's conditional probability, right? From here, what is this? It is Bayesian theorem, right? Bayesian theorem. Okay? Okay, let's get to another question here. Any questions? Okay. Okay. So we know mu x is equal to 40 and sigma x squared is equal to 81. Questions? I hear murmuring, so what's your questions? Anyway, so let's get to this part. We already know mu x is equal to 40 and sigma x squared is equal to 81. And now you are required to find out the probability here. So p x less than or equal to 67 and greater than or equal to 13. So this is the first one. The second one, p x greater than 58 or x less than 22. So in this case, for any distribution, if you want to know the probability, you need to know what kind of distribution that is. But in this case, we don't know anything about this distribution. We only know the mean is 40 and the sigma x squared, that's the variance, is equal to 81. So in this case, what should we do? Because we don't know the probability distribution function of x, this random variable. So we have to apply a different theorem. That's Chebyshev inequality. Okay, we have to apply Chebyshev inequality. And so what is Chebyshev inequality? It says probability of this x minus mu x less than or equal to k sigma x, then the probability is greater than or equal to 1 minus k squared, 1 over k squared, okay? So in this case, for the first question, it should be easy, right? And on the other hand, because this one is asking for the other two sides, right? So if you're going to revise, okay, this formula, you can do this. P x minus mu x, okay, greater than k sigma x, okay, then it should be less than or equal to k sigma, 1 over k squared. Why? Because if you add this one and this one, what should be the probability here? It should be equal to 1, right? Because you have only two areas. One is within this interval, right? And one is, of course, beyond this interval. So let me put it this way. Of course, we don't know anything about this distribution. We don't know what it is. But let me use this diagram, and this is normal distribution, right? But you know, this will not be, necessarily be normal distribution. So this is mu x, right? And this is k sigma x, okay? K sigma x. So the first probability is talking about this area, right? Okay, this is about this area. And what about the probability here? It is about this area and this area, right? Because for the probability for the whole thing, how much should it be? It should be equal to 1, right? And if here it is 1 minus k, 1 over k squared, what should be the other two here? It should be equal to 1 over k squared, okay? Okay, so the formula is here, and you want to try to find out what is the k, okay? You want to try to find out what is the k here. So in this case, we know mu x is equal to 40, and sigma x is equal to 9, right? And so here we are trying to figure out, let us rewrite the formula here, okay? So it should be x minus 40, right? X minus 40, okay? And now it is 67. So in this case, what does that mean? You have to subtract this by 40, right? If you subtract this by 40, how much should it be? It is 27, right? If it is 27, so what should it be here? It should be 27, right? Okay, so in this case, we can try to figure out if this is correct, okay? Let us try to figure out if this is correct, okay? So this is our trial, okay? We sort of figure out it should be something like this. And let us expand it again, okay? Because if this is the formula here, right? If we want to get rid of the absolute value, okay? If we want to get rid of the absolute value, it should be x minus a less than b and greater than or equal to negative b, right? Okay? And then it will be x less than or equal to a plus b and greater than or equal to a minus b, okay? So in this case, if we want to get rid of that, 40 has to add 27. What you get? 67, right? And then 40 minus 27. How much should it be? 13. So it is exactly the same, okay? Exactly the same. So in this case, we know how much is k? K is equal to 3, right? Because the number here is 27. And 27 is equal to k times sigma x, right? 27 is equal to k times sigma x. And we know sigma x is equal to 9. So k is equal to 3. So what is the probability here? It is equal to 1 minus 1 over 3 squared. So that's equal to 8 over 9. Okay? Any questions? So now let us get to the second part, right? Okay, if we do the same thing, okay, the mean here is 40. And 58 minus 40 is equal to 18, right? Okay, so let me put it here. So the second question is P x greater than 58 or x less than 22. And we already know, because mean is equal to 40, right? And 58 minus 40 is equal to 18. So in this case, how much should be A? How much should be K? K will be equal to 2, right? But you want to be very careful because that's on the other two sides, right? On the other two sides. So that will be this formula. So what does that mean? That means this one, the probability is equal to 1 over 2 squared. So that's 25%. Okay, that's 25%. So sometimes we may have this kind of question. You need to know what kind of formula you're going to use. In this case, that's Chebyshev inequality. And of course, you are required to calculate mean, okay? expectation variance, okay? Any more questions? Okay, let's get to another one. Okay, now we have three things here. Students will choose majors, okay? Their major may be business major, or engineering major, or linguistics major. And for all these students, they are required to take language classes. 20% of them take Japanese, 76% of them take English, and 4% of them take German. And also we know the choice of major and their languages, classes, is independent, okay? So whether you will choose business, engineering, or linguistics, it is independent of your choice of language, Japanese, English, or German. So then, in this case, what is the probability? So later on, when I put down probability, I'll just put down PROB. It's easier that way, okay? What is the probability that you get a business students and also takes Japanese. Okay, what's the probability? You have these numbers, okay? You have information about their majors. And then you have information about the probability that they take classes, okay, for 3 different kind of language classes. And so now, we are asking you, what is the probability that you choose a business student and also he takes Japanese? So basically, you have to translate the whole thing into a formula, okay? So in terms of a formula, what is that? So now you are asking, he is a business student and also he takes Japanese, right? So it is the probability that it is a business major and also he takes Japanese, right? So what does this mean? You are calculate the probability that it is a business student and also he takes Japanese, right? And we also have information about the relationship between a major and the language classes they take. What's the relationship? They are independent, right? So what does this mean? If they are independent, then you are trying to get the probability of B and J. So what should that be? It is probability of B times probability of J, right? So then probability of B, what's the probability they take business major? That's 0.42, right? What's probability J? 76%. Okay, so that would be the answer. Okay? Any questions? Questions? Sure, but we are getting to take a rest. Okay, so now let's take a rest. Let's take a rest.